Hello, Optimus. I'm going to post the link to the live stream. Just give me a moment here. And then we're going to talk about prime numbers. Oh, there it is. There's a link. Oh, there it is. The pattern in prime numbers. All right, cool. Yeah. All right, what do I do here? Okay, so let's switch this off and leave that and open up that. Okay. Now here's where I'm at with primes. So I've been exploring this idea that, and by the way, what I'm doing here is like research in real time. It's like exploration in real time. So I don't have all the answers, okay? But I really like, here, give me a second here. I really like this idea that you can think of primes as being not rectangular. After you get past, the first 1, 2, 3, just forget those. But you really want to start your primes at, and I'm drawing these through the phone screen. So if it's a little sloppy, I'm sorry, but you could start there, not prime, right? Because it's a square and a square is a rectangle. And then you can think of 5 as prime because you cannot make it into a rectangle. And that's really all there is to it. So you can go down the list like, okay, so 6 is not prime because it's a rectangle, right? And it's really that simple. There's this great website called Divisor Plot, and it shows you the pattern. So this is actually the pattern that generates primes. It's a very orderly pattern, and you can see that wherever there's a gap in this orderly pattern, and that's represented by these purple columns, that is where a prime is. So you can see that there actually is a very ordered pattern to primes. In the sense that the pattern comes out of the pattern of composites, and you can think of composites as being rectangular. And this will go on forever, right? And then primes start to whittle down as we go down the number line. So you really have to be thinking about like in 2 dimensions here, not just on a 1-dimensional number line, but in an X and Y axes. And I really like to think of them as not rectangles. I think there's really something to, if you look at a multiplication table, okay, like multiplication table, if you look like here, okay, there's your multiplication table. And you also know that, so you know that anything here is not prime, right? These are all composites, they're not prime, excluding the ones column in row. Other than that, everything here is not prime. And now you can think of every square is like the starting point for a new series. So you've got all these series of rectangles. Let me open this up in like Google Docs. I think that'd be a really good way to, or my favorite, Excel. So if you think about Excel, and then you can think of every new rectangle, every new square is the start of a new series. You've got 4x4. Oh, my phone's almost dead. I should go plug it in. I'm gonna go plug it in. Hold on. All right. Hey, friend. I just plugged in my phone. I'm doing primes and thinking about primes as not being rectangles. So if you think of like, okay, so it's 4 and you go 5x5, not prime. And when you're like, what do you mean, Gary, that it's not a series, that these are the beginning of a new series? So you go to 4, 5, 6, 5, 6. And then you can think of, okay, well then this is a series. What doesn't fit within this series? I mean, how could you then manipulate this shape? So you could also do this like that. You could also, it's like, how could you compress it? If you think of it being elastic, you could also go, it's 9, 2, 4, 6. No, that's the only way it can be compressed, right? It's the only way it can be compressed is like that. But then it's a series coming off of that until we get to the next series. That's what I was trying to say here. That's what I was trying to say. I think there's something to this. I feel like there's something intuitive here that I think has been overlooked. And I could be wrong. We're just exploring these kind of in real time, right? And what happened to my border? I didn't want the border to disappear. Oh, whatever. Okay, but it's like, okay, you can compress this to get to the next series. Okay, so here is 9, right? And here is 16. And these are just straight off the multiplication table, right? So if you go 16, 25, 36, 25, 36. And then when you create one of these series, so you would go 4, 20, 24, so I think we need to start thinking about these as being connected by a series, perhaps. What I'm thinking about is, okay, if you start at a square, like it's easy to find a square number, right? So you could find a huge square number with like 100 million digits, right? I don't know. 100 million digit number, and you could find the closest square. What's the biggest square number with 100 million digits? And then would there be any way to then just continue that series and just immediately know if there's a prime in there? That's the question. Maybe I'm just being stupid. Maybe I'm just being a dummy. You have to continue the series all the way through, right? This is probably a dead end. I'm probably thinking dead ends. You have to continue the series all the way through. There is no real way to just start at a square. Start at a square and then figure out from there so you know that's the biggest number, and that you can get all non-primes below that number. There will be no number on this grid that is bigger than that number. Everything will be smaller. So you have to search down here, but actually not even that whole thing, just this quartile, because that is where, because it's symmetrical. Maybe it doesn't make sense to do these on YouTube live, but it's kind of fun. Kind of like it. So it's symmetrical. Will there be any number on this line that is smaller than the next prime? Yes. I mean, you go all the way down to here and it goes all the way to 19, right? So you really have to search this entire line. But then we can start making numbers disappear. There's only certain numbers that appear on any line. And that's very algorithmic. So if you go like here, the pattern in primes, just give me a moment here. Did it not open up? No, that's not what I wanted. That if you just go here and we could just make a new data set. And I will just open up a new workbook. And then you could just go like, I had one. I was making one of these. 2, 3. And you can just complete the series. And then you can complete the series this way. 3, 4, 5, 6. And it's like, how far do you want to complete the series? Well, we can like make it pretty big, right? Go all the way down here. complete the series. And then if we go here, did I really not save it? That's so silly. Because I had it saved. I should really clean this lens, huh? How did I do that before? It was like, okay, so now this is 2. That was how. And you just multiplied it by itself. So let's imagine you get some enormous prime number. All right, let's think here. You get some enormous prime number, and you would be able to eliminate a whole bunch there. Just by, this is a bad episode. Should I cancel this one? I should have, maybe this doesn't work. I was thinking like, can you do like research in real time with live stream? And I don't know if it works like that. I've seen Wolfram do it. It's kind of boring though, right? Just me sitting here and going, You're gonna see me thinking, yeah, just thinking. That's what I'll do. I'll just sit here thinking. Just sit here thinking. Anything comes to me. You have to search between those two primes. That's a good question. So if you have your multiplication table, and you select between two squares, and you go diagonally. So that's why I had this open. Okay, so we select here, and now let's say our prime, this is the biggest number. The words are hard to find, dude. Like, I feel like the words just aren't there. But you go across. And you do this for 2 of them. So like this way. And then this way. Now the question is, will you find a number what am I even asking? Okay, if we took a prime, we were selecting a prime. Here's what I was asking. If we're trying to find some candidate between these two numbers, what is that? 81 and 100. What primes are between 81 and 100? Let me look this up real quick. List of first 100 primes. Okay. So let's say, okay, 97. Let's pretend we don't know that 97 is prime. I'm gonna write down. We don't know that 97 is prime. And we're like, is 97 prime? So we take this square and that square, and we're searching this way. And if we go, okay, it's like, oh, we don't see, and remember, this is symmetrical. It's perfectly symmetrical. So we only need to do this way. We're like, oh, I don't see 97. Could be prime. I don't see 97. It could be prime. I don't see 97. It could be prime. So you got 99, 96. But does that mean any number along this line is prime? Like 98 is on here, right? Let's say it was 98. Let's do 98 as our candidate. And we know 98 is not prime, or it's not prime. Well, where else do we see 98 here? Right there. But I thought there would be no number bigger than this. Wasn't that one of our assumptions, that if you had 100, so I guess that's wrong, that if you pick any number under this square, well, that was a wrong assumption. Because there's that one, that one, that one, that one, that one, that one, that one. And it's this arc. Oh, that was the arc I saw when I did this in a spreadsheet. And there was that arc. Yeah. And if you pick between two numbers, it gives you that arc. Because you really do have to search way over here. Do you have to search this entire thing? No. Well, how far do you have to search? I mean, if this is like 31, what numbers are smaller than 31 that are above that? I mean, up here, what numbers are smaller than 100 that are above this line? Here. And what numbers are bigger than 81 that are above this line? So what are the numbers between 81 and 100? Yeah, I saw this pattern before. It creates this arc. Yeah, I saw that in the spreadsheet I created earlier, which I didn't save, but I could remake it. I could remake it. I could remake it. And it's going to be like this. It's going to be like an arc. And I bet there's an equation to that arc. And then you just need the equation to the arc. And I wonder if you could then like specify it very exactly. Like we only want would that work, dude? Well, that'd be like saying, well, if you have all the numbers there, I mean, the problem is that even creating the grid is computationally insane. So you're basically just asking the same question of, you know, what numbers between such and such. Is the arc the pattern? Is that what we're really looking for here? You say, what are the numbers between those two numbers? I think we have to recreate our grid. I can't believe I didn't save it, dude. All right. Hey, friend. I can't believe I didn't save the grid I was working on. That's so silly. I have to remake the grid. Of course, all my battery's running low. Never enough battery power. How much battery is left? 49 minutes. All right. And then because it's a series here, it's like, let's just carry this series down here. I made this, and now I'm remaking it. That's silly. Should I show you what I'm doing? So I'm remaking, I'm basically making a multiplication table. So this equals this times, and then you use these here. What? No. Oh, okay. I think you have to put the and then you put these money signs. It makes it static. I thought it was, is it not yeah. Yeah, see? And then when you carry that down, yeah, that's what I was trying to do. And I will promise to save it this time. And then, yeah, this is how I did it. Okay, then we're going to go here. We're going to do the same thing, equals that times that. And we're going to use the money signs. And then we're going to carry that formula all the way down. And then, what? Is that right? Yes. Okay. And then because we've got a series, that was how I did it. This wasn't that hard. Now we can just, yeah. Right? 4, 6. No. This doesn't feel right. Okay, 2, 4, 6. No, this should be 8. Okay, so what's the problem here? Oh, okay. I'm going to copy and paste all these, but only the values. We're just trying to make a gigantic multiplication table. Copy, edit, paste, just the values, not the formulas. Okay, now we can go continue the series, I think. Let's check. Yeah, 2, 4, 6, 8, and this should be 3, 6. Yeah. Great. Okay. Yep. And we can just go all the way to the end and just make this as big as we want. And we can do the same for this way. Let's make it as big as we want. And then we just go here over here, drag it down. Yeah, sweet. Okay, that made our gigantic multiple. Now we've got a gigantic multiplication table. Now save it, Gary. I didn't save it last time. All right. I'm just going to call it giant multiplication table. Save. Okay. Oh, we should probably make those bigger. Or just have it so, can we just go here and, no, I don't want to wrap it. No, not that. Home. Why can't I don't want to wrap it. Page layout. Formulas. Let's go here. And let's just, I guess, make this bigger. Yeah, because I just want to see the numbers, that's all. These numbers at the bottom, are they gonna... There we go. Okay. All right. File, save. Now what I really want to do is just, I wish there was a quick way just to highlight all the squares. No, not that. Should I just do it by hand? Why does this feel stupid? There's got to be a way to do it that's not by hand. People always get so mad at me for using Excel. Don't use Excel. You can't use it. We're using Blackboards. Yeah, I'm sorry, dude. You're using a Blackboard and I'm using Excel. That's why I'm solving these problems. If you were using Excel too, you would solve problems like these too. Anyway, is this really the fastest way to do this? Just one by one, huh? Is this necessary to do it this way? I feel like it is. It's like, why isn't there a faster way to do this? primes is like something fundamental, but it's also a construct, you know, because we're only talking about whole numbers, and we're not talking about, you know, decimals. Because if we were talking about decimals, it would change quite a bit, I feel like. The question is, like, what's the fastest way to find a big prime? Can you imagine if we got the world record for biggest prime? How awesome that would be. There's this program called GIMPS, GIMPS, and they've got like the past several world record primes. This is going to take a while, isn't it? Like, dude, I don't want to spend all day just calling those in. I just want to start seeing results. Isn't that how it always is? Okay, so if we go to here, and then we go to conditional format, new rule. So here's the question. Like, let's just test this. So let's say we want to find a number, cell value between like 200. What would happen? And 202? Do you always have to go up by twos? And then we're going to format it with fill with blue. What happened? They fall on this line. I think that's, see how they fall on this arc? That's really interesting. I noticed this before, and that's why I remade this, because I wanted everyone to see that. There's something to that. There's clearly something to this. Here, watch. I'll zoom out even further. See how they fall on this arc? There is clearly something to this. Okay. So then the question is, okay, you need to find the equation of this arc. And then you only need to search along that arc. And is there like any pattern to that arc? There's clearly something. I mean, look at that. Am I wrong? Is there not clearly something to that? Like, what's going on there? Let's go manage rules. Let's do a new rule. Let's say it's between 200 and 210. I don't know. Let's just see what happens. Okay, now you can more clearly see that. All right, what is going on there? Does anyone know what's going on there? This is just a grid of numbers. It's a multiplication table. And it creates these arcs. And it very clearly falls on what happens if we extend it outward. Manage rules. Let's make this number even bigger. 200 to 300. These numbers, if you look at a multiplication table, everything highlighted is between 200 and 300. So it creates these arcs. I mean, surely somebody else has seen this before, right? Or I can't really just be the first. That would be crazy. What if we did 200 to 200 and it would just pull back. It would just give you 200 and 201, right? So this shows you where 200, 200, no, 200, and it's symmetrical. So it gives you, I use this word arc, it's a parabola. Yes, I know it's a parabola. what would it take to fill in that entire arc? How many numbers do you need to select to fill in the entire arc? Is that a good question? So if you go here and you go 200 to 200 and what do we say, 10? We already did that, but I just want to look at it again with like fresh eyes. No. And what numbers are here? Because you got 208, 216. Like, what would it take to make them all touch? You would have to go higher and lower. So you have to go from 200, about 220 to 2, I don't know. Could you write an equation to satisfy this? I'm sure there's smart people. And then if you did, because, okay, this is something here, obviously, right? There's something here. And then you only have to search along that line. So when you know the manage rules, $200 to $210. We already saw where 200 is. What else can we do here? Not between. That'd be kind of cool to look at. Equal to, not equal to, greater than. Ooh, let's try that. Greater than 200. Let's see what happens. It's going to create that arc. Yeah, see? Now you can see it very clearly. Okay, so that's what we're dealing with here. That's what we're dealing. This is like, feels like very like calculus, doesn't it? Doesn't this feel like calculus? Okay, this is what we were dealing with. If we, let's zoom in here. And let's just make it more granular. Okay, now you can see. Okay. Yeah, now you can clearly see the parabola. Like you've got a parabola. And it's got a limit, right? It's creating this limit. And where is the, it's at the square. It's creating these limits, and then it's, there's a word for it. The highest or lowest point of the parabola. What is it, vertex? At the square? But is that really at the square? I don't think so. It would be if we selected it to be at the square, I bet. So we went here, and then we went home, conditional formatting, manage rules. Let's pick a square. Here, hold on a second. Let me find a good square number for us. No. Let's just use 100. It's just simple. Or 1000. Okay. I bet the vertex. Is that not at the square? Why does it feel like it should be? It definitely should be, because it's symmetrical. It's probably just because of these squares are not correct. They're like kind of rectangular squares, cells. It's a perfectly symmetrical data chart. So what does this tell us? Like, I don't know. I'm trying to figure it out. It tells us that, is it even useful unless we know? Like, what if it's a big number? less than or equal to, less than, greater than, not equal to, between. I think it's between. There's something to that. In 2000 and it seems like the problem here, I feel like the problem here is that it's still super computationally heavy. Like, you still have to create the data chart. So if you're creating this prime, that's like, if you're trying to figure out if some massive number is a prime, like some number with, the world record's 24 million digits. So let's say we want to build the world record. 24 million, not 24 million, 24 million digits. Okay, to put that in perspective, the Bible is like 3 million characters. So multiple Bibles stacked up on top of each other. That's what we're dealing with. And it's just a number, right? So imagine we want to beat that. Say we want to beat like 25 million. That would give us the world record. 25 million digits. So it's basically like, you know, it's a lot. So what are we going to do? Just create a data chart of that? I mean, you can't even write it out. You'd have to use scientific notation, obviously. So you do scientific notation, and then you do like +1, +2, +3, +4 to represent it. And then you could probably even like simplify it further. Just be like, okay, X equals this scientific notation. Oh, yeah, exactly, Gary. Yeah, exactly, Gary. That's exactly right. So, okay, that's easy. And then it's just the assumption that this pattern holds true. Then it's just the assumption that this pattern holds true at all scales. So that's the question. Does that pattern hold true at all scales? That's the question. But the bigger the number, I'm just thinking. Feel free to chime in. Got a friend watching. Hey, friend. Hey, optimist. We're optimists here. I mean, that pattern holds true at all scales, right? Let's look. I mean, if you went between, I mean, 10,000 and 10,000, no, 10,000 and, damn it. I knew I had to plug in my computer. I swear it told me I had like 45 minutes left. It told me I had 45 minutes, and then it just disconnected on me. If I plug it in, I bet I could just maybe reboot it from where it was. Maybe? Maybe? Oh. Okay. Yeah. Okay. 10,000, 100,000, 10,000. Let's just 10,005. Okay. Okay. And then that's the pattern it gives you. Are they just getting more and more spread out? But are they really? I mean, the prime can only look at it's along these arcs, right? That feels like very significant. And we already know, okay, a prime cannot be certain. Okay, so here we know that we can find this arc, and it either will or will not be along this arc. And now that we know the arc, does it have a pattern to it? That's the question, I think. I think that's the question. Okay, so already, okay, we've got the arc. We can create these arcs. Arcs. Is the arc pattern always the same? And if we could solve that, that should make this a lot easier, right? Because then we would just look along the arc. We would have to, how big do you have to make your arc? Isn't that the problem here? Isn't that the problem here? No. Because the arc gets bigger and bigger and bigger because it's massive. I mean, think about how big this arc is. And that was just for, so it's still computationally expensive. That was just for 5. We wanted to search between 10,000 and 10,005. What if we wanted to search between, and to do that, we had to create this gigantic arc. So it's still computationally expensive, and that's the problem, right? I mean, how big do you have to make it? You have to keep on making it bigger and bigger and bigger and bigger. But maybe it's scale, like you can scale it. Wasn't that what you were saying, Gary? Wasn't that what you were saying, that you can scale it? Maybe. Like, is the pattern here the same as the pattern for 5? Like, let's imagine, like, we just cut a 0 out of here. Okay. Okay, so there's our pattern. Is that pattern just scaling? That was 5, right? We were searching between 1,000 and 1,005. Does that pattern just scale? I know how to do this. Let's create a new rule. Let's create a new rule. Okay, so we're going to go here. Okay, so before we said 1,000 and 1,005, right? Let's look at 1,005 and 1,010. And we'll format that with orange. They're on the same line. What about Rosie? 5 more minutes, okay, and I'll be done. I'm gonna delete that rule. 1,100 and 1,105. Let's make that green. Okay, yeah. That's kind of what I thought. Okay, so okay, that's big. Is that big? That the arc jumps. We can jump the arc. The arc represents the decimal value, or like the place, yeah, the tens position. Oh, look at that. That's weird. What did we just do to it? We just changed it. Wow, that's really strange. This feels very fundamental. Like we're doing something very fundamental here that is not typically done. Doesn't it feel that way? We're searching coordinates on a multiplication table. Okay, what's going on? Okay, let me just think here. Okay, only 2 minutes left. Just an hour a day, dude. That's it. So imagine you had some gigantic number. And you just have to search across some mammoth arc. But you could automatically eliminate a whole bunch of numbers. What do these dots represent? They represent... I've only got 30 seconds left. I'll do this tomorrow. They represent composites. They don't. Well, yes, they do. They represent composite because you've got composite numbers here and there. So these represent composites. And is there any way to identify the composite? Well, of course, you just go up and down, up and to the side. Oh my gosh. Hey, friend who's watching. I'm gonna call it a day. I've been live streaming for an hour. We're just trying to find patterns and primes. I think it'd be really cool if we could get the world record for biggest prime. It's 25 million digits. Anyway, I think I'm gonna live stream again tomorrow. All right. So this will be uploaded if you want to watch where I was doing what I was doing. It'll be uploaded. All right. Later.